Right, so from the study guide, this is on page 8. And on page 8, it said just 5 and 6. So understand, I make the study guide looking at the 9-week test. And then I made these slides looking at the study guide. You know, I didn't go back to the test. So if there's it's not exactly the same thing. I don't want to just like tell you the test question. But in general, it's, you know, can you plot points? Do you know what the coordinate plane is? Do you know, where is x positive? Where is x negative? Where does x equal 0? Where is y equal 0? Do you know all those things? That's what you're expected. There'll be questions where that's important. Okay, so that's why I put these on here, right? You know, these plotting points, you certainly ought to be able to do that kind of thing. You know, maybe, you know, even these questions here might be useful in getting ready for that kind of a question. You know, like telling what quadrant you're in based on the sign of x and the sign of y. Right? What quadrant would you be in? Like number 14 here. It says the product xy is greater than 0. Which quadrant are you in? Right? So let's see, let me draw. Okay, x is positive and negative. Y is positive and negative. When is it that the product x times y is positive? Somebody said the first. Okay, that would work. But that's not the only quadrant. Where else? Right, the first and the third, the product is positive because a negative times a negative would also make a positive. Okay, where in the coordinate plane would xy equal 0? At the origin, that's 1 point out of infinite. The x-axis, okay, there's half of infinity. And the y-axis, right? If the product equals 0, then you're either on the x-axis or the y-axis. Okay. So you should know that much about the coordinate plane. I mean, understand, I think I've already put this out with the study guide. You know, there's going to be 20 questions that are multiple choice. There's going to be 13 that are true, false. That, you know, this kind of stuff is going to be amongst those questions. And if you don't really know the coordinate plane, which you may think, well, that's not pre-calculus, but hey, if you got to this level and can't answer that kind of question, it's going to hurt, okay? You should know how to know the coordinate plane that well. Okay, this comes from page 19, 23 to 32. How do you find x and y intercepts of a function? Right, in order to find the x-intercept, you set y equals 0 and solve, right? So in this first one, you would say y equals 0. 0 equals 5x minus 6. Add the 6, divide by 5. There's your x-intercept. How do you find the y-intercept? Set x equal to 0, okay? So just remember those two basic strategies. In order to find the x-intercept, substitute y equals 0. In order to find the y-intercept, set x equal to 0. Did you have a question, Logan? No? Okay. You know, a basic piece of knowledge that we should have at this point. Right, the directions for this problem say, these are coming from page 32, 51 to 53. It says, write the equation of the line through the given point has the indicated slope. But if you notice, what are all the slopes here? What kind of lines have slopes that are either undefined or 0? Say again? Okay, which one is vertical and which one is horizontal? Taylor? Try again. Vertical is undefined. Horizontal is 0, right? Remember, a slope of 0 means that it's not positive, it's not negative, it's right in the middle of positive and negative. And just think of the number line we're using. What's right in the middle of positive and negative numbers? 0, right? The undefined is straight up and down, because just think, you know, what do you think of slope? Slope is the change in y per change in x, but there is no change in x. You know, you'd be dividing by 0. So if you had to come up with the, let's look at number 51. If you had to come up with the equation of a line which has an undefined slope and goes through 6, negative 1, what would it be? X equals 6, right? It's a vertical lines are named what x equals, right? And what does x equal? Well, what does x equal at that point? It equals 6. So it has to be x equals 6. And then how about the 53? This one has a slope of 0. Therefore, the equation is y equals 5 halves, right? That's this one. That's this one. So you definitely need to know that much about lines. Okay, these problems, this is 40, 65, this is page 32, 65 to 68. And it has to do with the parallel and perpendicular lines. And I just say that when I made this study guide, there were problems that were down here where it was find the equation of the line that has perpendicular to this line or parallel to this line. Those aren't the problems that I put in. The problem that I put in was like this, where you actually already have the lines. They want us to go through here and say which pair of lines is parallel, which pair of lines is perpendicular, and which are neither. Well, what do we know about the slopes of parallel lines? They're the same, right? So if I go through these here, I should be able to tell which are the parallel lines pretty quickly, right? Because they're all in slope-intercept form. Which ones show parallel lines? Yeah, these are the same, right? 1/3 and 4. So those are parallel, right? Okay, what do we know about the slopes of perpendicular lines? Bryce? Opposite sign. That's not all. Say it again. And reciprocal fractions, right? So, like, for example, one line has a slope of -4/5. The perpendicular line has a slope of 5/4. Opposite sign, flip the fraction, right? That's perpendicular. So where does that leave us with number 67? 1/2 and -1/2. They're not equal, and they're not opposite sign, flip the fraction. They're just opposite sign. So that would be the neither. Right. So parallel means same slope, perpendicular, opposite sign, flip the fraction. Okay. Okay. How do you tell when looking at a bunch of ordered pairs whether or not you're dealing with a function or not? X values don't repeat, right? So in this problem, let's say we did number 10, okay? Because you're probably more comfortable with this one anyway than number 9. But let's say you're talk about number 10. Which one of these, A, B, C, or D, is a function? You see, letter A has got repeated C's. That's not good. Letter B is A, B, and C. So that's probably going to be it, but I'll just check the other two anyways. 1, 0, 2, 3. Is that a function? Sure. So actually, that's a function and that's a function. And what about the last one? Yeah. C, B, A. That's good. So the only one that wasn't a function was letter A. Okay. Easy stuff, right? Okay, what do you call these things? Piecewise defined, right? How do you evaluate a piecewise defined function? For example, on number 31, how do I find f of -1 for this piecewise defined function? Okay, well, which one is it, Pierce? Right. Remember, these here, they're not part of the function. They're the domain. They're telling you where to use which expression to define the function. Right? This is for x values less than 0, use this. So f of -1, -1 is less than 0, so you would say f of -1 is 2 times -1 plus 1. Okay. Okay. And how about f of 2? Yeah, since 2 is greater than or equal to 0, you would use the second one, f of 2, which is 2 times 2 plus 2, which is 6. Okay, what about 0, f of 0? Why? Yeah, because the or equal to is here. So for the f of 0, you definitely want to be using that one, right? So that's evaluating a piecewise function. You know how to do that. But you can bet that there will be both options there in a multiple choice question, right? So pick the right one. Okay, difference quotients. Right? Can you do a difference quotient? Right, this is coming from, just I keep saying these things, 77 to 84, that's page 44. So let's see, you know, there's times when I think we do worse when they have numbers involved here. And I don't remember for sure. I kind of think this one has a number involved. So it's something like, let's say this one right here, number 78. Find f of 5 plus h minus f of 5 divided by h, right? The one thing that usually gives us the most trouble is how do you find this f of 5 plus h? I mean, here's the f of x. How do you find f of anything, right? You put in the place of x whatever the anything is, right? So if f 5 plus h is what you're evaluating the function at, then plug in f of 5 plus h equals 5 times 5 plus h, and then that's minus x squared, so minus 5 plus h squared, right? You're just putting in the place of x, 5 plus h. Simplify, right? That'll be 5, oops, let me stop that. 25 plus 5h minus, okay, how do you do the 5 plus h squared? Another place we'll make a mistake. It's a FOIL, right, of 5 plus h times 5 plus h, which would give us 25 plus 10h plus h squared. Right, that is a common place to make a mistake, and also a common place to make a mistake is that since you are subtracting that, right, that's going to flip the sign of everything inside. So, did I? Oh, yeah, I did that wrong. Thank you. It should have been like this, h squared. Okay, now we've got 25 plus 5h minus 25 minus 10h minus h squared, right? And then there's some simplifying here. We could say the 25s are going to cancel, right? These cancel. 5h minus 10h, negative 5h, and we got our minus h squared, right? That was all the f of 5 plus h. Now, now we have to subtract the f of 5. Where do we get that from? Just plug it in, right? There's your f of x. How do you find f of 5? Plug in x equals 5, right? So f of 5 will be 5 times 5 minus 5 squared, which is, right, which is 0. So now when we subtract the f of 5 plus h minus f of 5, right, the 0 didn't make any difference. We just get our negative 5h minus h squared. Right, that is all the numerator of the difference quotient. Now we have to divide by h. Right, and as always the case in these problems, the h in the denominator should cancel with h's in the numerator, right? You've got an h here, and you've got two h's there, so this one cancels completely, and this one cancels one of them. So what's left is negative 5 minus h. Does that look right? Ouch. Okay. So difference quotient. Now, these problems which come from page 56, 7 through 10, right? There's two things going on in these problems. I believe the reason that I went there, because it's the only one that had these kind of directions, were for the domain and range. That you ought to be able to look at a graph and tell what the domain and the range is. Remember that all of these graphs are made up of infinitely many points. you cannot list the points in the domain and the range because there's infinitely many of them, right? Instead, you're going to have to give and I'm going to have to reuse this word, right? Range of values using inequality symbols that describe or give interval notation to describe the domain and the range. Like in a problem like this, we would expect that these are going on forever, right? This is going on forever, 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 right? And you know, it doesn't look, especially this first one, there's a little bit of a tilt to the left, so it's going infinitely up and infinitely to the left. This is going infinitely up, infinitely to the right. So what would the domain of that be? It's going infinitely to the left and infinitely to the right, so the domain is all real numbers, right? Is it going infinitely up and infinitely down? No. What does it look like rounded off? The lowest y value is? Yeah, like -4. So let's say, we would say the domain for that one, and I think they probably used interval notation on the test. It was all real numbers, -infinity to infinity. But the range was -4 to infinity, right? The lesser value is always on the left. And then whether or not you want to call that a or equal to or not, I mean, you're kind of just estimating from a graph. That one honestly did not look like it went all the way down, but if you went like that, that's okay. How about a cubic function like that? What is the domain? All real numbers, right? These are infinitely left and right, infinitely up and down, so domain and range, all real numbers. How about this one here? Domain is all real numbers. I mean, there is a point of discontinuity here, right, where the graph kind of jumps on you. But at that value, at x equals 1, it's clearly defined, right, at x equals 1. And then there's an open circle at 1 for the other piece of the graph, and it goes on from there. So it's all real numbers. What is the range of that one? Y is greater than -2, right? It's going infinitely up, but it actually starts open circle at -2. So this range would be -2 to positive infinity, like that. Okay. Now, I don't believe there's any of the other part of these where it says like find f of 2. That should not be that big of a deal, even if it was, right? How do you find f of 2? Go to x equals 2, then what? Follow down to the graph, and then read off the y value, whatever it is, right? That's how you find the value of a function, just looking at the graph. Because in all of these here, they didn't give us an equation to plug into. You just have to be able to estimate it from the graph. Okay, what were these again? Vertical line test. What does the vertical line test tell us? Whether it's a function or not, right? So in this first one, is it a function? Yeah, it looks like it. I cannot see any piece of that where it looks like a vertical line would cross in more than one place. How about the second one? You know, this fails a vertical line test because you can clearly see where you could draw a vertical line and it would cross in more than one spot. So that fails. So this is the function, right? This is not a function. Easy. There was this one was 11 through 14 on page 56. I didn't put the 13 and 14 because they like jumped columns. I think we got everything we need out of it right there. The next one was the 25 to 30. It says specifically, use your calculator to find the zeros. Right? How do you use your calculator to find the zeros of a function? Right, you put it on the y equals, and then you just look at the graph, right? How about we do one like, I'm going to do this number 29, right? So go to the y equals, and I'm going to just for fun use the fraction format, right? Alpha, y equals 1. so that it's going to bring up the fraction. 3x minus 1. Now I don't need all the parentheses. And x minus 6. Okay. Do we see any zeros? Where? It looks like right there is a 0. Okay. How do we have the calculator tell us what the 0 is? You go second, trace for calculate, and there's 0 right there, number 2. I don't believe you have to do this on the thing. It's obvious. It's at one of the integer values. You see it in the table of values. But, this is the way we can find any 0. For a left bound, I'm just going to enter an x value, -2. Okay, and now for the right bound, I'll put in 2. Come on. Enter. And then, do I want to guess in between those two? Sure. And it looks like it's 0.333333, which is 1/3. And again, if you looked at this thing here, it says verify your results algebraically. Well, 3x minus 1 equals 0. Solve for x, it's 1/3. I mean, when it says, and I believe it does say on the test note, do this by looking at the graph. I mean, in the end, it's a multiple choice. Just get the answer right, whatever way you do it, right? Get the answer. Okay. Increasing and decreasing. So let's do one. How about we try number 42? Y equals, clear, 3x to the 4th, 3x hat 4. Get out of the exponent, minus 6x squared. Good, good graph. So, okay, what does it look like the graph is doing up until this point? I can get it over here. Right, from here until here, you would say that it's decreasing. Let's just say that that's exactly at -1, okay? Then what would that interval be? -infinity to -1, right? X values only, right? And so you can see it looks like it's bottoming out at -3. Don't use the -3. These are X values. Okay, what about this interval then from here to here? -1 to 0, and what is it doing? Increase, right? And then from 0 to 1, decrease, and then from 1 to infinity, increase, right? Okay. Okay. These are all the transformations, right? So let's say if you start with the parent function is f of x equals x squared. How do you show a shift of 3 units to the right and 7 units down? How do you add or subtract numbers in the function and after the function to make it go up, down, left, and right? No. Okay, so you're saying 3 right, x plus 3 in parentheses? Is that what you're saying? 3 right and 7 down. Okay, well, that's wrong. Is that right now? What's wrong? Yeah, it has to be -3. -3 inside means right, plus means left. Right, so you don't want to. Okay, what if it was a flip across the x-axis? How would you show that? A negative in front of the squared term, right? So just know your basic transformations like that. Okay, how do we do all these combinations of functions? Now, I think from the study guide here, this is page 81, 5 through 12, and it says specifically A and B. Okay, so if you notice up here, A and B are add and subtract, which means you're not going to get asked a multiply or a divide. The divides end up usually being the more difficult because it's always got a domain question with it, right? But you're going to get an add or subtract. Just take, for example, number 5. Right? How is it that I add f plus g of x? Remember, you're going to see the notation looks like this, f plus g in parentheses of x. But what does that mean? It's a f of x plus a g of x, right? And then how do we do that? You substitute for the f of x and the g of x, right? So put in the place of the f of x, put x plus 2. In the place of the g of x, put x minus 2, and then simplify, right? The 2's cancel, you get 2x. Okay. What if that had been a minus here, and here, and here? Well, what if that is a minus here, and here, and here? Okay, what do I have to change? Bryce? I mean, you have to take this, it's subtracting the entire x minus 2, which is going to make that a plus. Okay, so remember, that's why subtraction sometimes is a little more difficult, just because you got to remember, since you're subtracting something that has more than one term, it's going to flip the sign of everything. Right? So that's minus x plus 2. Now it's the x's that cancel and the 2's that add to give you 4. So know how to do that. Then we had 31 to 34. Can we find a composition of a function? All right, how do we do, let's take number 32. How do we do f of g of x? Yeah, I mean, and if you don't, I mean, it's a multiple choice test, but generally, we usually rewrite it as f of g of x, right? And we're going to call that f of, and then replace the inner function with what it equals, which essentially means now we're going to take that 5 minus x, and we're going to put it in the place of the x there, right? To stuff one function into the other, which is 3 times 5 minus x plus 5, which is 15 minus 3x plus 5, which is 20 minus 3x. Right. Now I want to see what the next one says. No. What if this question, and they didn't have a lot of great questions on this for me to give, so I'm just trying to remember, but I believe that the question may be more like this. Find f of g of 2. What if it doesn't have an x there, it has a 2? Well, if you've already calculated the f of g of x, then you just plug it in right here, right? That would be 20 minus 3 times 2, which is 14. But remember, you could also do it like this. You could say f of g of 2, and then evaluate. What is g of 2? In the same problem, what is g of 2? 5 minus 2. Just evaluate the inner function, right? Don't worry about plugging in the whole function into the other. Just say, what is g of 2? 3, right? So make that f of 3, and then you go right to the f function and say 3 times 3 plus 5, which is 14, right? Same thing. It should be the same thing. Good. Okay, determine whether a function has an inverse, and if it does, then find the inverse. Okay. What is the test that we use to determine whether a function has an inverse? Now you're talking about finding the inverse. What do we look at to tell us whether there's any point of finding the inverse? What's that? Horizontal line test. Remember that? Right. So remember, a vertical line test, like if I had y equals x squared, it's a function. It passes a vertical line test. But it doesn't have an inverse because it would fail a horizontal line test. Right. So the check to see whether something has an inverse is called the horizontal line test. What do you call the function if it passes that test? This is important because I think this phrase comes up several times on the test. I didn't write the test, okay? Or at least not that part of it. 1-to-1, right? If a function has an inverse, it's called 1-to-1 if it passes a horizontal line test. And so horizontal line test means 1-to-1. Oh, come on. Means yes, inverse. Okay. So let's say that a function you've already determined that your function has an inverse. How do you find the inverse? How about we take, I'm going to take number 63, which is a little more complicated than the rest. Turn the f of x into the y, right? Y equals x plus 3 squared. Switch the x and the y. X equals y plus 3 squared. Then what? Solve for y, right? Well, now our y is inside parentheses being squared. How can I undo the square? Take the square root of both sides, right? So when I take the square root of both sides, I'm just going to show that kind of funny, right? Then this becomes y plus 3 equals plus or minus the square root of x, right? And then you subtract 3, right? So now we've got y equals negative 3 plus or minus the square root of x. Now there was one more step that they gave. Yeah, change the y back to f to the minus 1. Okay. But there's still something wrong with that, right? You know, and this was the tricky part of finding inverses. That remember that when you switch the x's and the y's, you're switching the domains and the ranges, right? This thing, we were given a domain statement, which was that x is greater than or equal to negative 3. What does that tell you about the range of that? Y is greater than or equal to negative 3, right? But if it's both the plus and the minus, that's not true, right? In order to make it just greater than or equal to negative 3, you don't have the minus, you just have the plus. Okay, now that the lowest value would be negative 3, and this is always a positive number. It will just go up from there. Right. So remember, you would expect that these, you know, this right here is a parabola with the vertex on the x-axis like this. Right. But the fact that they said for x greater than or equal to negative 3 means don't draw both sides of the parabola. Just draw the part that starts at negative 3 and goes up from there. You know, if you drew the whole parabola, you'd be like in this situation. It wouldn't pass the horizontal line test. But by limiting it just to the right half of the parabola, now it passes the horizontal line test. Okay, just that when I do this thing here, that was going to give me something that looked like this. 1, 2, 3. You know, it would go up like that. That's the positive branch. And then down would have been the negative branch. But then that wouldn't be a function. So it couldn't be a part of the inverse. So it just has to be the positive half, the plus, not the minus. Okay. Okay. So this was, now jumping to chapter 2. Right? How do you write a quadratic equation in standard form? What the book calls standard form. Right. What is a standard form? No, that's point slope form. Right. So we've done enough of these things, I think. How about if we do number 22? Right. How do I put that in standard form? Okay, you could do negative b over 2a, right? What would negative b over 2a calculate for you? It would get you the h, right? So in this case, it would be negative h equals negative 12 over 2 times 1, which is 12 over 2, which is 6. Right? How do I find the k? Right? Plug this 6 in here. Right? So f of 6 is 36 minus 72 plus 44, which is 70, 80, which is 8. Right? So that's telling us we know the h and the k. Where did we get the a from? Yeah, the original one had an a of 1, so the standard form has an a of 1. So this is f of x equals 1, which you don't show, x minus 6 squared plus 8. Okay. What was the other method to put it in standard form? You could have completed the square, right? You could have gone to the middle term, divide the middle term in 2, right? Negative 6, square it, 36, right? So that would have given us f of x equals x squared minus 12x plus 36. And then outside the parentheses, we would have had the 44. And what would I had to have done? Because I just added 36 inside the parentheses. Subtract 36, right? Okay, and by doing that, you'll see this next step, it would have been x minus the half, right? And 44 minus 36 is 8. Which part of, when you look at any of these here, like let's say number 19, what's the y-intercept? The constant, right? The constant is always. How would you find the x-intercepts? Set h of x equals 0 and solve, right? Same way we already talked about finding intercepts. It works the same way. Right? Leading coefficient test, right? So remember, the leading coefficient test depends on 2 things. What are the 2 things? Is the leading coefficient positive or negative? Okay. And then what? The degree, right? The degree is the highest power of x that you see. So what if we looked at something like number 21? What is the degree? It's squared, right? And what is the leading coefficient? Positive or negative? Right? So don't worry that they didn't write it as the first term. The highest degree term is x squared. The leading coefficient is negative 3. Right? So if it's got a even power, even degree, and a negative coefficient, describe its end behavior, or right-hand and left-hand behavior. Falls to the left, falls to the right. Right? That's an easy one. That's a parabola that opens down. Falls to the left, falls to the right. What about one like 27? Okay, 27, even better. What's the degree? It's 7, which means it's odd, right? So, and then the leading coefficient is positive or negative? It's negative, right? So remember, these things are true for all odd degree functions and all even degree functions. It doesn't matter if it's a 7 or a 1, it's going to have the same behavior. So asking a question of what's the end behavior for a 7th degree polynomial is like saying, what's the end behavior of a line, 1st degree, with a negative slope? Describe the behavior. Rises to the left, falls to the right. Same thing. Right? All odd degree functions will behave the same in terms of this end behavior. Right? So you don't have to get worried about the 7th degree. You know, oh my gosh, how many bumps in it does it have? 6. How many zeros? 7. but that doesn't make any difference, right? It'll behave, as far as this end behavior goes, exactly like the most simple odd degreed function. Okay, so rises and falls, left and right. These are the only two that I put on here. And they're kind of simple, to tell you the truth. But if you remember, this is where we were doing the rational zero test, right? So what did the rational zero test tell us? Possible rational zeros, meaning zeros that could be written as fractions, which also means that they're real, right? Real numbers. And so how did we determine that? Yeah, it would be the factors of 16 divided by the factors of the leading coefficient, right? And these problems here, the leading coefficient was always 1. But I believe in the problem, there was also some aspect of like then looking at a graph and telling which are the actual zeros. That's why I put these two on. What if this leading coefficient here was 2? Right? Then it would have been the factors of 16 over the factors of 2. Right? And what are the factors of 16? 1, 2, 4, 8, 16, and then divide those by the factors of 2, you would have gotten 1 and 2, and then what? That's not the list, is it? You got to go through and take all the combinations of what's in the numerator and the denominator. So obviously, when you divide anything by 1, you get the same thing: plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Okay, now do the same thing over 2. 1 over 2 is a half. And then 2 over 2 is 1, already got it. 4 over 2 is 2, already got it. 8 over 2 is 4, 16 over 2 is 8. So we already had those. Yeah. But just know what you're looking for. If it was written in reverse order, it's still the factors of the constant divided by the factors of the leading coefficient. Okay, find all the real solutions. How do we go about finding all the real solutions to a polynomial like that? I mean, let's take, for example, 32. I mean, what would you suggest we start by looking at? The graph, right? You'd probably look at the graph. I mean, could you do a leading coefficient test? Yeah, a rational zero test? You could. But even if you got a whole bunch of those things, which you know are not necessarily zeros, you're probably going to look at the graph and tell that anyways, right? Now, this would get more complicated if some of those zeros are irrational, right? So let's say I go y equals, clear, x to the 5th, x hat 5th. I mean, I can tell 1 0 right now. Can anybody else? 0, right? Because every term has that in it. Minus 3x hat 3 plus 5x squared minus 2x. Then I look at the graph, and what do I see? It looks like -2 is in there. It looks like 0. We know 0 is in there, right? And what else? If we zoom in, zoom to, it looks like 1 is in there also. And you can confirm that by going to the table of values, right? Yeah, look at that. -2, 0, and 1. And does anybody else recognize anything that looks like it might be going on at that 0 right there? It's got like maybe it's not raised to the first power. It may be raised, it's got to be raised to an odd power because it's going through the x-axis. But that's not just going straight through. My bet is that we've got 3 factors of x minus 1. Now, how could you do that? You go over here. Let's say we said negative 2, 0, and 1. Well, let's see. Let's factor out the x first, because that's the easy one. X to the 4th minus x to the 3rd minus 3x squared plus 5x minus 2. Right? The 0 we already know. Okay, now let's do synthetic division. 1, negative 1, negative 3, 5, and negative 2. And we're going to divide out a bunch of zeros. How about the negative 2? Negative 2 times 1, 6, negative 6, 2. Okay, so I took out the 0. I just factored out the negative 2. Now let's factor out a 1. Right? 1 times 1 is 1. 1 times negative 2 is negative 2. 1 times 1 is 1, 0. So 1 is clearly a 0. We already knew that. But what do these 3 represent now? It's a quadratic, right? And what is the quadratic? X squared minus 2x plus 1. And if you solve that, that's x minus 1 squared equals 0. So what are the last 2 zeros? 1 and 1. So we actually had 1 as a 0 3 times. Okay. So remember, if you have to find all the real zeros, you're definitely going to look at the graph as a starting point. Okay, find all the vertical and horizontal asymptotes. How do you find vertical asymptotes? Right? Vertical asymptotes are zeros of denominator, right? So, for example, 14, what is the vertical asymptote? X equals negative 2, right? And then how about horizontal asymptotes? How do we find them? Elena? What does it depend on? The degree of the numerator and denominator. Okay, number 14, right? This has a degree of 2 in the numerator and degree of 1 in the denominator. What is the horizontal asymptote? None, right? When the numerator is higher degree, none. Horizontal asymptote? None. What's that? Okay. CERM is saying that is there a slant asymptote? How do you know? Because the degree of the numerator is exactly 1 more than denominator. How would you find the slant asymptote? Divide the numerator by the denominator, right? So 4x squared divided by x plus 2. All right, that'll be 4x squared plus 8x. Subtract minus 8x minus 8. Okay, so I did the long division. Now, what part of that is the slant asymptote? Just this part right here, right? That is slant asymptote. Okay, which one of these in here? What would the horizontal asymptote of number 9 be? A horizontal asymptote. Say again. Why? Because the degree of the denominator is more than the degree of numerator. This one would have been y equals 0. Okay, what about one like number 11? What's the horizontal asymptote? Negative 1. Remember, it's because these are to the same power. It's the ratio of the coefficients, which is 1 over negative 1. So y equals negative 1. Okay, now for these problems here, that was 49 through page 177, 49 through 60C only, right? And that's the slant asymptote. That's in there just for the slant asymptote. And since we just did that on the previous slide, I won't stop on that one. Okay, there's going to be a problem that looks something like this. Remember, these were our rational functions, and I believe the way the problem is, it's just asking you to evaluate. Like in these steps here, would say find the cost of supplying 15%, 50%, and 90%. What did you do with those values? You plugged them in, right? There. These were homework problems anyways. Come on. Just plug them in. You know, if you had to find like an asymptote, you'd find them just the same way as we did on the other problems. 24. Solve inequalities. I'm not going to go over that because we just did that in the homework. But there is, I think, one problem like that. Now, there will be some, and these are, you know, more the true-false variety, but, you know, knowing the sets of numbers. What is an integer? What is a rational number? What is an irrational number? You know, you should be able to put things in the proper sets. Tell me, in this list right here, which is an irrational number? What kind of number is -7 over 3? It's a rational number. It's a fraction, right? Rational numbers are fractions. We got to know that. Which is the irrational number? The square root of 5. An unresolved square root, right, is a irrational number. Let's see. Do they have anybody else see a different kind of irrational number on there? No, 3.12. Decimals that terminate or break into a pattern are rational. Okay. But something that's got pi in it, that's an irrational number. I think they're trying to show, like in this one right here, -13, what is that? No, 0.010110111. They're trying to show a decimal that's not terminating and not breaking into a pattern. That would be irrational. Okay. What are integers? I mean, so in this top list, which are the integers? Is -9 an integer? Yes. Positive and negative whole numbers are. Is 5 an integer? Is 0 an integer? Okay, and 1 and -4 and 2 and negative, so they're all integers, right? Properties. Right, these, in our book, they call these basic rules of algebra, but these are things like, do you know what the commutative property is? Right? Order doesn't matter. Do you know what associative property is? Grouping doesn't matter. Do you know what distributive property is? Everybody knows that one, right? What is the identity property for addition? What number do you add to anything and get the same number? 0. What's the identity element for multiplication? 1, right? What is the inverse property for multiplication? What do you multiply by a number to get 1 as the answer? The reciprocal, or 1 over, right? Something like that. So know the properties. These are the only examples they have. And here's a couple. I think these are the last two. True, false. This is the nature. Some of the true, false questions will seem like this. They might even include these. I don't even remember. Every non-negative number is positive. Is that true or false? Why? Because of one number. What number is that? 0, right? 0 is non-negative, but it's not positive. So that would be a false. If A is greater than 0 and B is less than 0, then A times B is greater than 0. What would it be? If one is positive and one is negative, when you multiply them, what do you get? You get a negative, okay? So that would be a false. So again, this is the study guide. I just went through every group of problems and showed you pretty close to what was going to be on the test. I'm not picking it up before the test. There's no retest. I'm not making 2 versions of this test. So you come in, you do it once, and that's it. And it'll be graded instantly. I can tell you how it affects your grade.